Welcome to Tool Projects. In this video, we are going to explain about a project titled Machine Learning Based Prediction of Impulse Control Disorders in Parkinson's Disease from Clinical and Genetic Data. So now coming to the introduction part. In the realm of Parkinson's disease, the convergence of machine learning and medical investigation has paved the way for fresh insights into comprehending and forecasting complications linked to the ailment. And especially noteworthy obstacle in the management of Parkinson's disease is the onset of impulse control disorders, that is ICDs, which can markedly affect the well-being of individuals. The implementation of an innovative machine learning predictive model crafted to foresee the manifestation of impulse control disorders by amalgamating clinical and genetic information marks a groundbreaking advancement in this domain. So now coming to the objective part for this project is to deeply connect it to the pressing requirement for precision medicine in the field of neurodegenerative disorders. Parkinson's disease is characterized not only by motor symptoms but also by non-motor complications, among which ICD presents a notable hurdle. This endeavor seeks to harness the considerable capabilities of machine learning algorithms to scrutinize extensive datasets encompassing both clinical and genetic data with the aim of constructing a resilient predictive model. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of project, here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and Seaborn for visualization are important. Second, here we have exploring the dataset Parkinson's data status. So in this step involves loading and examining the Parkinson's disease dataset. Understanding the structure and content of the data is crucial before proceeding with any analysis or model building. Then we have data processing using Pandas data frame. This step involves loading and examining the Parkinson's disease dataset. Understanding the structure and content of the data is crucial before proceeding with any analysis or model building. Then we have data processing using Pandas data frame. Utilizing Pandas data frame to clean, pre-process and organize the dataset. This step may include handling missing values, encoding categorical variables, and scaling numerical features. The next we have visualization using Seaborn and Matplotlib. Creating visualizations to gain insights into the data. Seaborn and Matplotlib are popular libraries for generating various types of plots and charts to visualize patterns, correlations, and distributions in the data. The next we have feature selection and splitting the data for DL. Using techniques to select relevant features for modeling, splitting the dataset into training and testing sets for both traditional machine learning using scikit-learn and deep learning using Keras. Then next we have building the model. Developing machine learning models using various algorithms, support vector machine, random forest, decision tree, logistic regression, XGBoost, voting classifier, recurrent neural network, gated recurrent unit. Then we have training the models. So in this we have to fitting the models to the training data, allowing them to learn and underline patterns and relationships. Then we have building the model with voting classifier, since it gives better score comparing with other models. So in this, using the voting classifier, which combines the predictions from multiple models to improve overall accuracy, this step suggests that after evaluating different models, the voting classifier yielded a better score. Next we have Flask framework with SQLite for sign up and sign in. Integrating the Flask web framework with an SQLite database for user authentication, that is sign up and sign in. Flask is commonly used for building web applications and SQLite is lightweight relational database. Then we have importing the packages. It is similar to the previous step which I have told you about the NumPy, Pandas and Matplotlib. Then now coming to the user gives input as feature values. Allowing users to input feature values likely related to Parkinson's disease. Next we have given input is pre-processed for prediction. Pre-processing the user input to ensure it aligns with the format expected by the trained model. Then we have trained model is used for prediction, employing the previously trained machine learning or deep learning model to make predictions based on the pre-processed user input. And the last one here we have final outcome is displayed through front end, presenting the prediction outcome to the user through the front end of the application, which could be a web interface created using Flask. So now coming to the execution part. To execute the project, first we need to open the code folder. So now here you can see that we have a folder which is named as templates. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Then we have another folder which is named as static. This folder consists of files related to CSS, JavaScript, and Bootstrap files. Next here we have .ipynb file, which is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data science. Next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. Then here we have signup.db file. This file appears to be the database file which is used to store the information. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and the space the path over here and hit the enter button. Now type python app.py and just now hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. Just paste the link over here and now hit the enter button. So here you can see that we have got the home page for the machine learning based prediction of impulse control disorders in Parkinson's disease from clinical and genetic data. So here you can see that there is a button for sign up. Just click on it and enter your username, your full name, email ID, your mobile number, and your password for doing the registration. I have already done the registration, so here I am clicking on sign in button. So just enter your username and the password over here which you have created while doing the registration and simply click on login button. So here you can see that you have to enter the credentials over here. Suppose here you have to enter 1, here 1, for the jitter also 1, ABPS 1, for RAP 11, for PPQ 1, Shimmer 1, Shimmer DB 1, APQ3 1, for Shimmer APQ 5, again APQ 5, DDA 1, NHR 11, Spread 2 1, Spread 1 1, DFA 1, RPDE 1, HNR 1, for D2 1, and for PPE 1. And now just click on the predict button. So let me check it over here. Enter the DFA and click on predict button. So here you can see that it is showing the outcome based on the credentials which we have provided over there. It is showing the test result as positive, and for the percentage of risk as 99.10%, for the risk level as high. So depending upon the parameters we are providing over there, it is showing the result, whether the result is positive, negative, or neutral. So here you can see that there is a button for about. Just click on it, and by scrolling down below here you can see that there are many different graphs, and based upon the algorithms we are getting the accuracy for all those graphs. Now you can see that there is a button for sign out. By clicking on this button we can simply log out with this. So now coming back to the conclusion part. In summary, the investigation into a predictive model based on the machine learning for detecting impulse control disorders, that is ICDs, in Parkinson's disease patients represents a noteworthy advancement towards personalized and proactive healthcare approaches. The convergence of clinical insights and genetic information made possible by sophisticated machine learning algorithms offer great potential in deciphering the intricate factors influencing the occurrence of ICDs. The findings of this study not only enhance our comprehension of the intricate relationship between clinical and genetic aspects in Parkinson's disease, but also set the stage for tangible advancements in predictive medical practices. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Project's YouTube channel and subscribe.